Relating slope and y-intercept to linear equations. Lesson 7 notes. The review is a separate assignment that goes by the same name, relating slope and y-intercept to linear equations, but it says notes review. So go into Schoology, find the notes review for lesson 7, upload it to Notability, complete it there, and then resubmit it to Schoology. It's better if you do that than it's just it's just the notes review, not the whole set of notes. Also, there is a video, so find the video for this. It helps walk you through some of the problems. And in the video, I completely do number 5. So find the video, upload this to Notability, and complete that there. All right, so again, this lesson is on relating slope and y-intercept to linear equations. So this whole lesson is going to be on linear equations. Take a moment, pause your video, and write down the definition for similar figures. So you need to write down this definition right here. Okay, so similar figures. It's when geometric figures have the same shape but not necessarily the same size. I often use the example of a square. I could draw a square that can fit in the palm of my hand, but then I could also go out onto the football field and draw a big giant square. And they both would have 90-degree angles. They both would have 4 congruent sides, or 4 sides that have the same length, and they would be similar figures. They're not anywhere near the same size, but they're the exact same shape. You've dealt with similar figures in 6th grade, possibly even some in 7th grade. Anyway, so I want to prove to you that rectangle ABCD and rectangle WXYZ are similar. I want to prove to you that they are similar. I'm going to start by putting the two, or the letters for each figure on top of one another. The reason why I did this is to show you that A corresponds with W, B corresponds with X, C corresponds with Y, and D corresponds with Z. So I want to prove that these are similar figures. And to prove that they are similar figures, then they are going to be proportional. And again, we dealt with proportions in the last lesson. All right, so we're going to show that they are proportional. And there's 2 ways to do this. The first way that we're going to do it is compare the ratio of corresponding sides to a ratio of other corresponding sides. In other words, I'm going to take the ratio of AB over WX and set it equal to the ratio of BC to XY. And then, so that's one way. We're doing corresponding sides. The other way is to do figure to figure. The ratio of 2 side lengths compared to the ratio of 2 side lengths on the other figure. So we're going to start with AB over WX. All right, so the length of AB is 9. The length of BC is 6. The length of WX is 12. And the length of XY is 8. So what we're going to do is we are going to simplify these fractions. So I'm going to put 9 over 12, and I get 3/4.
Add the new Google widget right to your home screen.
Sorry about that. Gotta love the commercials. Anyway, so 9 over 12 would give me 3/4, and then 6 over 8. Same thing, 3/4. So for the first one, we got 3/4 on this side and 3/4 on this side, which means they are proportional. Since the corresponding side lengths are equal to one another, the ratio of corresponding side lengths are equal to one another, that means they are proportional. The ratios are equal, therefore they are proportional. All right, so now we're going to do it by comparing side or figure to figure. We're going to compare figure to figure. So let's start with the length of AB again is 9, and BC was 6. WX was 12, and XY was 8. So now let's simplify these fractions. So 9 over 6 is 3/2. And then 12 over 8 is also 3/2. Because these are proportional, that means the figures are similar. Because the side lengths are proportional, the figures are similar. So you need to write down, because the ratio of the side lengths are proportional, the figures are similar. Pause your video and get all of that written down. Again, pause your video and get everything written down. Okay. Now, if you remember, linear equations have a proportional relationship. Linear equations have a proportional relationship. That's what the last lesson was on when we did proportional relationships in lesson 6. So if you have a linear equation, then there are proportional relationships. So we're going to be using that throughout this lesson. If you have any question on similar figures, please let me know.